Welcome to this video tutorial involving compound interest and the two key problems that are maybe the most troublesome involving compound interest. Perhaps you want to pause and try these problems before we discuss together. Okay, in this problem, we know that we end up with $107,519.33. The original amount was $34,000. 1 plus the interest rate, which we don't know, we'll call it x, divided by the fact that we're compounded monthly. Now, compounded monthly for 15 years will tell us what the overall exponent should be. So 12 times 15 is going to be 180. That's our exponent. Now, we are going to graph to solve. We will make one side of the equation y1. We will make the other side of the equation y2. But in this problem, the key thing is that we're solving for the APR. So x is going to be small. X is going to be a percentage. X is going to range likely between 0 and now if we think about 10%, which would be a lot of interest, that's 0.10. So when you're looking at the x window, you definitely want to keep that in mind. So we will go to our calculator and we're going to type these in. On the one side it's 107.519.33. And on the other side of our equation, it's going to be 34,000 times parentheses 1 plus the x divided by 12 raised to the 1/80th exponent. We'll go to our window. X min 0, x max 0.1 makes sense. We might need to manipulate it a little bit, but that makes sense. And the y value that we need to see is about 107,000. So I'm just going to go from 0 to 200,000 with the y's. Seems like a wise thing to do. Hit graph. There's a nice picture. We will second trace to calculate. Option 5 for the intersection. First curve, enter. Second curve, enter. Guess, you can just stay there and hit enter. And here comes our answer. Looking at this answer, we get that x is equal to 0.077. Please convert that to an APR, which would be 7.70%. And I would like 2 decimal places on the APR. So please throw that 0 in there as well. That's our first problem. Here comes the second problem. In this case, we have $87,531.36 equaling the original amount of $52,000 times 1 plus, we know our APR here is 0.0521. We don't know how many compoundings. We'll call it x, and up here we'll put a 10x. Now, a couple of things. First, make sure you put parentheses around your exponent when we type this in the calculator for the y1 and the y2. If you don't do that, the calculator will misinterpret what you're saying. Secondly, we really need to focus in on this amount right here. So for the y window, we're going to want to zoom in there and maybe be like 87,400 to 87,600. Because the number of compoundings did not make that large of a difference in the amount of money in the account. So we will come back here and type these in. For the y1, it's $87,531.36. For the y2, it's 52,000 times parentheses 1 plus 0.0521 divided by x. Watch how your parentheses are matching up. Then put the parentheses around the 10x. If you don't, you will get an incorrect answer. We go to our window. In this case, x is the number of compoundings per year. Now, we might have it happen frequently or infrequently. I'm going to say 0 to 100, but then for the y min, we're going to make 87,400. Y max, we're going to make 87,600. Then we'll hit graph. That's a decent picture. Second trace to calculate. Option 5 for the intersect. Hit enter, 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 and here it is. So we get x equals 55 times per year based on that graph. But please watch your parentheses. Watch your window. Errors on either of those could lead to difficulties on a test.